coating is a powerful and well-established technique for depositing uniform, thin films onto a variety of substrates. When properly executed, this technique enables reproducible films at the nanoscale, providing critical capabilities for research in materials science, electronics, and engineering. In the spin coating process, substrates are placed onto a chuck and coating solution is deposited centrally onto the substrate surface. Generally, coating solutions comprise of the target coating material mixed with a suitable solvent. The substrate and chuck then undergo high-speed rotation, generating centrifugal forces which spread the liquid coating material radially outwards across the substrate surface. The solvent then evaporates, leaving behind a thin, even layer of the desired coating material. A successful coating is uniform across the entire surface, consistent in both thickness and coverage. At PI-KEM, our mission is not only to equip you with the tools and materials that are central to your research, but also to provide you with the expertise to maximise your equipment's potential.
In this short video, we'll highlight some of the unique features of the SCS G4 Spin Coater series. Using the G4, we will guide you through some of the common challenges faced when spin coating, techniques for optimising the quality of your spin coated surface, and maintenance tips to help you get the most from your spin coater. To kick off this video, let's talk through some of the unique features of the SCS G4 Spin Coater series and what makes it valuable in both research and development environments. The SCS G4 Spin Coater holds operating precision and programming flexibility at its core. Engineered with high levels of rotational accuracy and process repeatability, this spin coater allows you to deliver high-quality coatings with confidence. The G4 is available in 8 or 12-inch bowl sizes, each coated with PTFE for exceptional corrosion resistance against a wide range of coating materials. The G4 system is fully programmable, supporting up to 30 stored programs with 20 steps each. Each step in a coating cycle can be precisely defined, with fine control over parameters such as spin speed, acceleration, deceleration, and dwell time. Programming is achieved through an easy-to-use touchscreen, which is removable for use in glove box and fume hood configurations. When paired with SCS's proprietary Windows-compatible software, users can control their system via Bluetooth communication, enabling external programming, profile storage, diagnostics, vacuum control, low-speed centering, and a programmable park position. Finally, the G4 Spin Coater series features a number of safety features designed to protect both your substrate and your equipment. These features ensure that the lid is firmly closed and the purge air and vacuum connections correctly attached before the coater will operate. Now we're going to use the G4 Spin Coater to explore some of our spin coating tips, as well as using a blue acrylic paint to simulate a coating material, and coating on top of a 0.3mm silicone wafer.
Let's start by exploring some of the challenges you might face when spin coating for the first time. Some of the most common issues include using contaminated wafers, depositing your coating solution unevenly, or choosing the incorrect chuck for your substrate. These mistakes can manifest themselves in several ways. Your resulting coating may be patchy or uneven. Your substrate might demonstrate raised edges or thick rings. There may be the presence of surface phenomena, such as comets or pinholes. Identifying these problems is key to improving your results and optimizing the potential of your spin coater. To demonstrate this, we contaminated some silicone wafers in a number of different ways. Firstly, we applied glue and sprinkled over coarse salt to varying levels. This represents particulate contamination of the wafer surface. Here, several examples demonstrate that the resulting coating is not uniform nor consistent across the substrate surface. The contamination impeded the flow of the coating material across the wafer surface, resulting in an uneven and incomplete coating of the substrate. Secondly, saturated sugar water was applied to the wafer surface and allowed to dry. This represents residual contamination of the wafer surface. Once again, we can see that the coating achieved is irregular. Finally, to really highlight the effect of wafer contamination, we contaminated only half of the wafer surface, allowing you to see side by side the difference between a clean and contaminated wafer. Here, we can clearly see that the contaminated half of the wafer presents several of the surface defects previously discussed, whereas the clean half of the wafer presents an even and consistent coating across the surface. The quantity of coating solution and the location of its deposition must be carefully controlled in order to achieve a successful, high-quality coating. Determining the optimal amount of coating solution to be deposited generally requires some initial testing. The amount needed may depend on your desired film thickness, the viscosity of your coating solution, and the wettability of your substrate surface. Using too little coating solution will result in your surface not being fully covered. However, using too much will result in solution wastage. The coating solution should be deposited centrally onto the wafer surface. During the coating process, centrifugal forces cause the coating solution to spread outwards radially towards the edges of a wafer. If the coating solution is not deposited precisely into the center of the wafer, the final coating can have a hole in the middle where no coating material has reached, resulting in incomplete coverage of the substrate surface. The chuck is a critical component of the spin coating process, providing the interface between the spin coater and the substrate being coated. Selecting the correct chuck for each substrate is vital to ensuring the best coating results. Selecting the correct chuck is vital for substrate security and stability. The chuck firmly holds the substrate in place without any wobbling or vibration, even at high rotational speeds. This prevents defects in the coating film, but also prevents the substrate from being damaged due to becoming loose during the coating process. Furthermore, the chuck helps to withstand the rotational forces generated by the spin coater without any warping or breaking of the substrate. Specialized chucks can also be tailored to support unique substrates. For example, where the substrate is especially heavy, where the substrate is a unique shape, such as a microscope slide, or where the chuck is flexible, such as metal foils. Let's review best practices for achieving a high-quality spin coating result. This will include how to precisely deposit your coating solution and optimal techniques for handling and storing your wafers. For enhanced precision when depositing your coating material, manual or automatic dispensers can be coupled to your spin coater, releasing controlled volumes of coating solution directly at the center of the substrate. Some spin coater models, including the SCS G4 Spin Coater, include guidance holes in the spin coater lid, ensuring centralized deposition of your coating material. The SCS multi-dispense system facilitates multi-layer coatings, allowing up to 4 solutions to be deposited sequentially with precise and repeatable solution volumes. As we've seen, contaminated wafers can severely impact the quality of your substrate coating. To prevent this, there are several techniques that you can utilize in order to keep your wafers clean and ready to use. Storing your wafers in specialized containers or cases is one of the easiest ways to keep your wafers free from contamination. Not only does this keep your wafer clean, it also prevents scratches or other surface damages, overall keeping fragile wafers safe and secure, especially when being transported. When handling wafers, it is ideal to use either gloves or tweezers. Not only does this prevent fingerprints from appearing on your wafer surface, it also prevents the transfer of other potential contaminants on your hands. Lastly, let's explore spin coater maintenance. Proper maintenance of your spin coater keeps it performing at its best, guaranteeing consistent and repeatable quality across successive coatings. Cleaning after use is an easy way to maintain your spin coater, preventing build-up inside the bowl and also mitigating contamination between successive coatings. Excess coating should be removed with a clean cloth, and then any remaining residue can be removed with an appropriate solvent.
Spin coaters from PI-KEM are supported by our in-house equipment specialists, trained by manufacturers for in-depth product knowledge. Customers can contact us directly for expert advice on operation, maintenance and troubleshooting of their equipment. Where further support is required, equipment can be returned to our UK-based warehouse for detailed diagnostics, servicing and repair, ensuring optimal performance and long-term reliability of your equipment. In practice, the SCS G4 Spin Coater series gives users the control, flexibility and repeatability required to develop and run coating processes with confidence. With the right techniques, informed equipment selection, and our expert support, spin coating can deliver consistent, high-quality thin films that you can rely on for your advanced research requirements.